following section deals with naming and writing ions. The first one is hydrogen ion. And so when we look at our flow chart for writing the formula, we have the first question: is the name a single word and or does it end in ion? We're going to answer yes to this whole section. We're going to end up starting out in this box because everything we're going to be dealing with in this section either ends in ion or it has a charge to it. So the word ends in this case does not end in ite, or ide. So we answer no to this question. That ends up putting us to this question was, does the name have a Roman numeral? Since it's just hydrogen ion with no Roman numeral, we answer no. So we're in the positive ion or a monoatomic cation. And all we have to do is write the symbol for hydrogen, which is, when we look it up on the periodic table, is H. And then we look at its charge. Well, hydrogen on the periodic table can have a positive or a negative charge to it. And so we have to look at the clue that it's just called hydrogen ion. And we use the plus charge +1 that's up there. So hydrogen ion is going to be just H+. And this is a monoatomic cation. Monoatomic meaning it only has one element, and cation meaning it's positively charged. The next one is C-4. So this is a formula, and we're going to be going to the naming of the formula and the answering the question, does the formula have a charge to it? It's got a -4, so we answer yes to that question. And there's only one element in it, that is carbon -4, C-4. So we answer that it only has one. And then, is the charge positive, which means cation, or is it negative? Well, it was negative. So we go here, and we're in this box here, and it says, name the element replacing the last syllable with "ide." And add the word ion. So this is going to become carbide ion, because instead of carbon, we replace the last syllable with "ide." And that was a monoatomic anion. And anion because it's negatively charged. So C2O4 with a -2 charge. This time we're not dealing with a monoatomic, we're dealing with a polyatomic ion. And so when we go to name this one, we end up in a different spot on this flow chart. We're going to go to where there's 2 atoms. So we end up using this box for naming polyatomic ions. And we're going to look up the formula on a polyatomic ion chart and write its name. So it's just a matter of going to a periodic table or a reference chart and finding C2O4 -2. And C2O4 -2, when we find it on the polyatomic ion chart, is named oxalate. So all I have to do is write the name oxalate. They don't need to know, you don't have to put the word ion afterwards, but it's not wrong if you do. So it's good practice anytime it has a charge to put ion afterwards. So oxalate ion, and this is a polyatomic ion. And it's a negative charge, so it's polyatomic anion. The next one is K+. K+, we go back to the naming, and we're going to end up, for naming K+, we're going to end up, it's a positive charge, and it's a single atom, so it's a positive ion, but single oxidation state. The way we know it's a single oxidation state is by going on the periodic table, finding the element, and we see that it only has one possible oxidation state to it, and that is the +1. And so we're going to be using right here, we're going to be using this first one, which is name the element and add the word ion. The element is potassium, and I'm going to add the word ion. And potassium ion is a monoatomic cation. And so we go to the next one, which is arsenite ion. The part that I key into right away is the last 3 syllables, or 3 letters, last syllable, and it's ite. So when you go to writing the formula on your flowchart, I'm going to ask questions on it. Is, since it's arsenite ion, the arsenite, it ends in ite. So we answer yes to this question. What are the last 3 letters of the name? Is it ate or ite, or is it ide? Since it is ite, we go down here and we're going to be looking up the name on the polyatomic ion and write the formula. So the polyatomic ion chart that we have, we're looking for arsenite. And arsenite is AsO3 on this polyatomic ion chart with a -3 charge. And we just write that down, AsO3 with a -3 charge. And that is a polyatomic ion because it has more than one atom, and it's an anion. Technetium, Roman numeral 4. The Roman numeral always indicates the charge of the atom. So when we go to writing the formula, we end up in this box right here because it has a Roman numeral in it, and it says write the element symbol with its charge based on the Roman numeral. Since IV represents 4, we're going to have a +4 charge on technetium. So Tc is technetium, the symbol for technetium when you look it up on the periodic table, and it's Tc +4. This is monoatomic because it only has one element, and then cation because it's positive. The next example, Ni +2. When we're naming this one, the question we end up, it's an ion, but we end up answering yes to this question right here, which does the element have multiple oxidation states? Nickel, when we look on the periodic table, is found right here, and how we know it has multiple oxidation states is by looking here, and it has a +2 and a +3 possible charges. So it's got 2 possible charges, or 2 possible oxidation states, or multiple oxidation states. So according to the naming chart, we're going to be using Roman numerals. Name the element with the charge as a Roman numeral and add the word ion. So Ni is nickel. And this is nickel with a Roman numeral 2 to represent the charge, and then ion. This is a monoatomic ion, or cation, monoatomic cation. The last one, arsenide ion, going back to the flow chart. To write the formula, we see that arsenide ends in "ide," and so we end up right here. This is an anion because it's negatively charged, and we're going to write the element symbol with the charge that's above it on the periodic table. So when you go to your periodic table and find arsenide, or arsenic, because that's just an element, arsenic's right here. If you notice, it's got multiple oxidation states here. You ignore those and just get the number at the top of the periodic table. So the arsenide, As, is going to have a -3 charge. And that is monoatomic because it's only one element and it's an anion.